Hello, my name is Benjamin Brodwolf, and in this video we will be taking a Java program called RayTracerTexture that calculates the UV coordinates for the sphere, and we're using them to map a texture onto its surface of the object file. So how it worked before was like it was mapping the texture onto a cube, but it didn't really work the same way. A cube has 6 flat faces, and each face can be treated as like a 2D plane. The coordinates were manually being assigned for each vertex. So this is really what was happening instead of calculating where the texture should be mapped. So you can see there's no output sphere over here in the file. And if I run the code here, you can see there's no errors, and that we get an output here of the sphere. The output is centered nicely, and the texture is mapped correctly to the 3D globe model. And I will show you the code I have implemented in a moment. This method here is responsible for calculating the UV coordinates for a point on the sphere, and it's the method I will be explaining for this video. It is a large portion of the functionality of the texture mapping process, and really is what guides the PNG file along with the points in the object file. You can imagine a common use case for this could be mapping a texture or a picture of the Earth onto the sphere object as well. This first line of code defines a method called calculate sphere UV, and it also takes in 3 parameters: point, center, and radius. Point being the point on the sphere where we want to calculate the coordinates for the texture, the center of the sphere, and the radius, which is the radius of the sphere to the outer edge, the center of to the outer edge. Then next we have this line, vector 3 d equals point dot subtract center dot normalize. So the purpose of this line is to calculate the direction of vector 3d here from the center of the sphere to that given point. So point dot subtract center is going to give the vector difference, so the direction from the center to that point where we're going to map that texture. And dot normalize is a method that's going to convert it into a unit vector, which is going to make the further calculations easier. Next we have this line of code. This is actually the core calculation that makes texture mapping possible. Without it, the texture wouldn't wrap correctly around the sphere, causing a pretty bad misalignment. This makes sure the horizontal wrap is perfect. So in a way, it's the bread and butter of the entire file. So math.atan2 d.z and d.x compute the azimuthal angle, which represent the direction around the vertical axis. And then we divide by 2 times pi, which normalizes the angle. And moving on, for this line of code, double v equals 0.5 minus that function is calculating the v coordinate, which represent the vertical position of the sphere. Math.asine d.y gets the polar angle, which is the angle from the vertical axis. Without it, it would also have misalignments and distortions. And lastly here, we have the return uv, the coordinate values, These are going to be used as the sample to know where to map the texture to. This is basically the coordinate that is going to wrap the texture around the 3D sphere.